8.9, we're going to return to some things about inequalities. So a linear inequality that has two variables is the result of replacing the equal sign with that inequality symbol. So instead of saying they're equal to that, we're going to say they're less than or greater than. We might also say less than or equal to, or we could say greater than or equal to. So the first example is going to be much like 8.8 when we were checking solutions. So we're going to get a coordinate point. We're going to substitute it in for our x and our y and see if that inequality is in fact true. That would make it a solution to that inequality. So the first statement, 2 times 0, we have 2x minus 3y is less than 6. So the first coordinate point, substituting in the x's and the y, we have 2 times 0, which would be 0, minus 3 times 1, so there's our negative 3. Is negative 3 less than 6? Pictured on the number line, is it to the left? Yes, it is. That's a true statement. The next one, we are going to use 4 and 2 with this same inequality and see if that's true. So our x, 2 times 4, minus 3 times the negative 2. Watch your integers here, is less than 6. So we're going to say 2 times 4 is 8. Negative 3 times negative 2 is positive 6. This equation is not a true statement. All right, now this is going to come in handy when we're checking points for graphing, which is what this lesson is about, graphing inequalities. So the graph of a linear inequality that has two variables is graphed very similar to an equality in the fact that we're still using the y-intercept and the slope. The part that is different is how we draw our lines. We have two different kinds of lines we may choose. And then also we're going to be shading all of the points that could be the solutions to the inequality. So we're going to start out with the one we used for our first example, 2x minus 3y is less than 6. We're going to go ahead and we're going to put it into slope-intercept. So we're going to get rid of our 2x on that side. We end up with negative 3y. We want to solve for a single y, so we divide both sides by negative 3, and we get y is greater than 2/3 x minus 2. Do you remember the rule about this? When we multiply or divide by a negative, we need to flip the sign. It was a negative. It was a less than. We have our negative right here, so we need to flip our sign. Those are all old skills we had. Now we're going to go to our skills that we've learned about graphing linear equations. So I'm going to go ahead and I'm going to go to the y-intercept first, which is negative 2. There is my first point, and now I'm going to apply my slope, 2 over 3. So that means I'm going to rise 2 and run 3. And I'm going to go ahead and I'm going to make sure that I label my points before I'm going to show you the next part. So my y-intercept was at 0, negative 2. Oh, easier to see than it is for me to write it, apparently. See if I can make it better, negative 2. And then my, applying the slope, my x is 3. I'm sorry, I don't know what's wrong with the writing again here. Try it one more time. My x is 3, that's much better. And my y this time is 0 because I'm right on the x axis. I don't know, it just seems to be little spots that it doesn't want to work. Okay, so let me show you the rest of graphing this. We know it's a linear equation, so I want a line that's going to go through those 2 points. However, now we're dealing with inequalities. And because this is a greater than symbol, and it does not have equal attached to it, it means the points that lie right on the line are not solutions. but the solutions that are greater than are. So what I'm going to do is I'm going to use a dotted or dashed line. It's actually a dashed line, but many people will refer to it as a dotted. But a dashed line, that means that the points that are actually right on that are not solution points. Now, the next part is we're going to shade the area that contains all of the possible solutions. In order to do that, I need to test a point. The easiest point to test is 0, 0. So I'm going to go back to what I did in that first example, and I'm going to test a point. So I'm going to substitute in here 0, 0. 0 for my x. So we're, oops, I'm going to get on the writing utensil. I really won't be able to write. So I'm going to do 2 times 0 minus 3 times 0. You can see why I chose 0, 0 as my coordinate point. And I'm going to see, is that true? Does that make my original statement a true statement? 6 is pretty ugly there. Looks a little bit more like 6. So 2 times 0 is 0, minus 3 times 0 is 0. So is 0 less than 6? If 0 is less than 6, that means the point 0, 0 would be a possible solution. 0 is less than 6, so I want to shade in the area. I'll make it a little prettier. We'll use blue for the shading. Shade in the area of the grid, the graph here, that is containing the 0, 0 point. So 0, 0 is part of the solution, so I want to shade in that side of the graph on that side of our solution line. Okay, let's try another one of those. So this time we're going to start out right away that my equation is in slope-intercept form. I'll take one step away from us. So again, start at the beginning, start at B. So my y-intercept is at 4. And applying my slope, I'm going to go up 2 and over 1. Okay? Now I'm going to make sure I label my points. I'm going to do that before I put the line in, just so you can see what we're doing. So my my y-intercept was at 0, 4. And my applied slope point is at, I might have to shade with something else so you can see my writing, if we can see my writing even before the shading, is at, the x would be 1, the y is at 6. So those are my two graph points. Now I'm going to go ahead and I need to look and see which kind of line will I be using. My inequality symbol says that my solution set will be greater than, but also could be equal to this answer. So I'm going to use a solid line because of the equal. And we were graphing equalities before, and this is an inequality, but it has the equal contained in it. So it's going to look very similar to the linear equations that were just equal then. The part that will be different is because it is an inequality, we will have some shading. So again, the easiest point to choose is 0 because it makes our math very easy. So I'm going to check 0, 0 or the origin. So I'm going to substitute in 0, 0 in my equation. So 0 for y. So is 0 less than or equal to 2 times 0, greater than or equal to 2 times 0 plus 4. Again, we like 0, 0 because it makes math very easy. 0 is my only term on this side of the symbol. 2 times 0 is 0, so I'm left with just 4. Is 0 greater than or equal to 4? That is not a true statement. So the point 0, 0 here, whoops, doesn't want to let me draw a point without moving my graph. So let me try doing it with my finger. So we checked this point here. We checked 0, 0. Okay? We checked the origin. It does not make a true statement. So I do not want the shading to occur on the side where 0, 0 is, because it is not part of the solution set. So instead, I want to do the shading on the other side of the graph line. So my shading would be over here. I think we have one more of those. We do. Uh-oh, a very famous one. X is less than 3. You don't need to put this one into slope-intercept form. Remember, if x has a value, and that is all, that's going to be a vertical line. A vertical line. X is always going to be 3. So I'm going to go ahead and I'm going to, try to grab one of my points here. And there is x is 3. But another x is 3. It'll let me grab a point again. There we go. X is 3 in this point too. It happens to be 7, 3, but x is still 3. So if I connected those 2 points, I would have the graphed equation. Now, my inequality symbol does not contain equal, so I want to use the dashed line. I'll make it a little bigger here. Now again, sorry, let's go ahead and make this a little larger so it's not so close to the point there. So there is my graph linear equation, but it's an inequality, so I need to think about the shading. This time I can still check this point 0, 0. X is 0 here. So if I put 0, is 0 less than 3? 0 is less than 3. So my shading is going to occur where 0 is part of the solution set, because the shading is representing the solution set. So I'm going to shade on this side of the line. Okay? So the things that you need to know, what you learned in 8.8, you still need to learn or know how to graph the linear equation part using your slope. Using your y-intercept first and then your slope. The new thing that you need to think about is which type of line am I using? And I get that from what kind of inequality symbol there is. If it includes an equal, then we want to have the solution set include all the points on the solid line. If it does not, we want to use the dash line. And then the last new step would be to check a point and see is it in its solution set or not. If it is not in that solution set, you shade the half plane made by that line. You shade the side that does not contain that point. We have another very special one. I think this is our last one for equations. So y is greater than or equal to 2. If I only have a value for y, give me my little, there we go, then y is going to be at negative 2. All my y's are going to be at negative 2. So we could do one here. Next step, look and see what kind of line includes equal to. So I want a solid line. And remember, these are the lines I keep telling you about. These are going to be horizontal lines when it's just y in the equation. There is no slope, there is no x, there is no coefficient to x. So we have a horizontal line. And now our last step, we have to consider how we are going to shade this graph. So when we're looking at this graph, I'm going to substitute 0 in for y. And is 0 greater than or equal to negative 2? It is. So the point 0 on the y-axis is going to be part of the solution set. So I want to shade above so that 0 is included in there. We're going to conclude this lesson with a real life example. So you have 100 pounds of clay to use for making bowls and vases. You need 5 pounds of clay for each bowl and 2 pounds for each vase. So if you look at this equation, this information, we have 2 different kind of variables. We have the amount of clay we need for bowls. We have the amount of clay we need for bases. So if we were going to write that equation, we would know that we have 100 pounds, whoopsie, 100 pounds of clay. We cannot use more than that. So we need to make sure that our variables can't be any larger than that. So we need to make sure that they have to be less than or equal to 100. We could use 100, but that's the most that we can use. So we have 5 pounds of one variable. We could make this B, but we're going to go ahead and just stick with our X's and our Y's. We could use B and V for bowl and base, but we're going to use our two variables. And we have 2 pounds for each base, which is going to be our other variable. So we have 5x plus 2y has to be less than, can't be more than 100 pounds, that's all we have to use, or equal to 100 pounds. So if we look at that, remember we talked about with real life situations, you couldn't say that we had negative pounds or we needed negative pounds of clay. So we really just have the side of the graph that has the positives. So if we went ahead and graphed this, we need to make it into a slope-intercept form, and then we could graph this equation. Now, it says graph the inequality from part A, and then give 3 possible combinations of bowls and bases that you can make. So what I'm going to do is I'm going to find points that I could, that are good intersecting points. Now, mine's not perfect here, but I could say, oh, it looks like if I was going to make, if I said this point right here. This looks like if I made 18, and we're going to use our X's are our bowls. So if I made, we'll say that that's about, maybe not quite 18. Let's say 16, because it's 10, 15, 20. We're going to say 16 bowls. That means I could make about 10. See how I'm going here? 10, and this is about 16. 16 bowls would let me make 10 bases. Or if I wanted to make 50 bases, that means I could make 0 bowls. Or if I made 20 bases, if it'll let me do a point here, I'm sorry, 20 bowls, these are my bowls, this is my X, oh my goodness. These are my bowls, which is my X, and these are my bases. I don't know if I'm going to be able to fit that in there. So if I made 20 bowls, I would not be able to make, this point is at 20, 0, so I would not be able to make any bases. If I made 50 bases, that's my y-intercept, that means I could make, my x would be at 0. So that would mean I have 0 bowls that I could make. So that's a real life situation with two variables. You'd still graph it the same, and then we would say that those would be the amount of bowls. Now I could make less than that. I could make 10 bowls, and I still could make 20 bases, and I'd have a little bit more left over. So if I was going to shade this equation, I could shade this equation, let's get blue again. All of these would be the possibilities without going over 100. So I could even make 5 bowls and 5 bases. And I would have a lot of my 100 pounds of clay left. And that concludes lesson 8.9 and also the last lesson of this chapter.